Welcome back to the channel, guys. So as you know that we are having a quick revision of atomic and molecular physics. In the first class we talked about Bohr's atomic theory and derived some relevant and important formula. So in part 2 we'll be giving you a most generalized formula to them, okay, and we'll also talk about variation of Rydberg and Rydberg constant. So let's go for the most generalized formula. So these formulas will help you to apply Bohr's atomic theory to any single electron atom. So most generalized formula. So you know, in some atoms other than hydrogen you get the concept of reduced mass. So for them this formula will be very much important. So the radius of the nth orbit, it has a generalized formula of m by mu n square a0 upon z. The symbols are carrying their conventional meaning. Z is an atomic number, a0 Bohr radius, n is the principal quantum number, mu is the reduced mass, m is the mass of electron. On the other hand, En, total energy in the nth orbit, it is given by minus 13.6 mu by m. Okay, it was m by mu, now it is mu by m, z square upon n square, and remember this thing that it is in electron volt. So for hydrogen you can get this specialized value by putting z equals to 1 and you can put mu equals to 1, then minus 13.6 by n square you will automatically get this, where your a naught is 4 pi epsilon naught h cut square divided by m e square. You already know it, we have also derived it on the last class, that is 0.53 angstrom. Then this is the Bohr radius. Another important quantity you should remember, that is the fine structure constant. What is the value of the fine structure constant? Fine structure constant is represented by the symbol alpha, that has a value of e square by 4 pi epsilon naught h cut c. This is precisely 1 by 137. So these were the most generalized formula. Mainly you are asked about radius of the nth orbit and energy of the nth orbit, and these are the formula, most generalized formula. Now let's apply this formula into the case of positronium. Okay, so let's discuss the case of positronium atom. You can give the heading positronium atom. Previously a lot of questions came from this positronium atom, so that is why it is of utter importance. What is a positronium atom? In positronium atom is basically a bound state of an electron and its antiparticle positron. So the positron is here and the electron is around it. So here we have positron and the electron is revolving around it. So it is also an one electron system. As I told you, Bohr's atomic theory is applicable to one electron theorem. So this also has one electron. Now you know what will be the value of Z for this positronium atom. Z is the number of proton. So here number of proton means here you can consider equivalently Z is equals to 1. Okay, that is a positron. So you can take the value Z is equals to 1 for positronium atom. If you calculate the reduced mass of the positronium atom, then how can we calculate the reduced mass of the positronium atom? The formula is m1 m2 by m1 plus m2. So here two electrons they are having the same mass, because antiparticle they have the same mass. Mass of electron divided by mass of electron plus mass of electron, m1 m2 by m1 plus m2. So this will give you me by 2. So using this we can calculate En positronium, the total energy in the positronium at the nth level. So you know that it is minus 13.6 mu by m. So minus 13.6 mu is me by 2 divided by m, so 1 by me, into z square by n square. Z is 1, so 1 square by n square. This is in electron volt. So what you get? You get minus 13.6 divided by 2n square in electron volt. Okay, so this is nothing but minus 6.8 by n square electron volt. In this way you can easily calculate the total energy in the nth orbit of a positronium atom. What about the radius in the nth orbit of positronium? It is m by mu. So m by mu is equals to me by 2. So me, so it will be multiplied with 2 into n square a0 by z. N square a0, z is equals to 1. So this is n square into 2a0. For hydrogen it was n square a0, for positonium it was n square 2a0. So it will be doubled. Okay. Now you know wave number. If you talk about the wave number is represented by this nu bar. It is proportional to E and it is proportional to the Rydberg constant R. So Rydberg constant R for positonium will be, because the energy dependency divided by 2, so it will be the Rydberg constant for hydrogen atom divided by 2. And velocity, if you consider the positonium atom, it will be same as the velocity in case of hydrogen atom for any state. Whatever state you consider, n equals to 1, 2, 3, so this will be valid for any states. In this way you can estimate the details of positonium atom in the most generalized formula. Let us now quickly talk about the variation of Rydberg constant. Okay, variation of Rydberg constant. Variation of Rydberg constant. So let's start with the definition of the Rydberg constant. Look, Rydberg constant is generally defined by considering the mass of the nucleus to be infinitely heavy. Okay, mass of the nucleus is taken to be infinitely heavy, and you got the formula of m e to the power 4 divided by 8 epsilon naught square c into h cube. But in reality, in practical, mass of the nucleus is not infinite. For that case, we define something called a reduced mass, mu, reduced mass. So for practical purposes, what you take, we take r mu. So instead of writing m, where you will be writing mu, mu to the power 4 divided by 8 epsilon naught square ch cube. Now we can express it in terms of m. Okay. Now if you consider the mass of electron to be small m and mass of the nucleus to be capital M, then mu can be expressed as m1 m2 divided by m1 plus m2, right? So m is equals to how much? You can just write mu by m into m. So this can be written as r infinity. Okay, so m e to the power 4 divided by this. So m you have taken in the numerators, you have to divide it by m. So mu by m, you need to calculate mu by m. So mu by m is capital M by small m plus capital M. So this will be, and this can be written as 1 by 1 plus small m by capital M, right? So it is like mu by m into m e to the power 4 by 8 epsilon naught square ch cube. So r infinity divided by 1 plus small m by capital M. So this is a very important formula. It gives you how your Rydberg constant varies with the mass number. M, capital M you can consider like mass number, because capital M is the mass of the nucleus. Okay, so if you represent the variation, look, if you plot the dependency or the variation of r infinity, sorry, let's write rz. Z will be, rz will be the Rydberg constant for atom with atomic number z. So we are plotting it against mass number. Then you will get a curve like this. Let's say here there are light nuclei, hydrogen, light atom, helium, lithium and oxygen 16, let's say. And as you can see, towards the heavy masses where the nuclear mass will be infinite as compared to the mass of electron, for that it will take up the value of the r infinity. So in this way you can understand the variation of Rydberg constant with mass number. You can take different example. Let's say if you consider for z is equals to 1 for hydrogen atom, you can write the relation 1 by lambda is equals to RH into 1 by NF square minus 1 by Ni square. For Z is equals to 2 for helium plus, this is for hydrogen, this is for helium plus, what you write? You will write 1 by lambda, it will be equals to 4 by 4 into RHE 1 by NF square minus 1 by Ni square. By using this formula we have, you can write it in this way. So in this way you get the variation of Rydberg constant with mass number. Now one problem is that if the Rydberg constant of an finite nuclear mass is alpha R infinity Rydberg constant corresponding to infinite nuclear mass, ratio of electronic mass to the nuclear mass. So basically you have to calculate electronic mass by nuclear mass. So take this as homework, you can do it by yourself and you can tell me the answer in the comment. Okay, answer it in the comment. I hope you have understood, and just simply using the formula you can get it. Answer the comment, give me an answer in the comment section. Okay, before I end this video, let me tell you guys, an academic goal is going on. Stay ahead in your preparation. This is the last day to get this special offer of 20% plus up to 1 month extension on CSIR-NET subscription. It's valid till May 31st, and if you use this referral code Physics Hub, will be getting the maximum benefits. You can go for June 2024 or December 2023, these benefits will be given. Now guys, you can also follow me on Unacademy Plus. I'm a class educator on Unacademy, and this is my profile. You can get all the 9 units of CSIR-NET Physical Science syllabus starting from mathematical methods to nuclear and particle by just taking a single subscription using the referral code Physics Hub. So in this way you can complete the whole syllabus, and lot of benefits are there of taking Unacademy Plus subscription. You get daily live classes, part length and full length tests, assignments with detailed solution, proper structured course, whole syllabus is covered, dedicated doubt-clearing session, and many more things you can pause and read. So take the Unacademy Plus subscription today and put your feet on step ahead towards reaching your goal. So this is all for this video guys. Thank you very much. If you are new to this channel, please subscribe the channel, don't forget to press the bell icon. Finally, thanks for watching.